Hello, Roderick. Now you're
Hi.
live.
Hi. Thanks for having me. I'm Roderick, and I'm here in California, United States, and very happy to share some experience with us.
Tell us a little bit about yourself, like who you are,
Sure.
what you work with.
I'm Roderick, and then I work for Tinder now as the web team, platform team, and then mostly we are doing a lot of things like related to progressive web app and how to optimize performance, and then also trying to push the web platform to be a better place for people to utilize. So then people won't have as you know, like Tinder is a really native app focused company. So that's why we're trying to push the web as well. Like web is equally powerful than native, and you can do a lot of things with web, and hopefully more people can make the web a better place. So that's my area of focus. So if any of the audience has question about the web in general or web performance or like anything that you want to try out for your company for like to utilize the web technology, feel free to reach out to me. And then I'm happy to be here to answer the questions.
Okay, and without further ado, let's play a talk.
Hello, everyone. Thanks for coming to the talk today. I hope you're all safe and healthy during the pandemic and enjoy all the sessions today. I'm going to share a bit about our learnings at Tinder related to how we progressively enhance our web application. When you first hear about Tinder web, you probably has the question or impression that, wow, Tinder has a web app? Yeah, it's probably the most frequent question I've been asked. If you haven't used it, I will strongly recommend you to take a look. There's a lot of fun feature and experiment we are trying on top of the web platform. As you know, Tinder is a really native app focused company. We start from the native app and we successfully provide our user fun and interactive user experience. So, why do we need to build a web versions of the Tinder where our native app is pretty mature at the market? To answer this question, I'm going to share a bit about our journey of exploring the potentials and the possibilities that we can have by using different web technologies. Traditionally, if we want to compare native and web application, we can probably dividing the strengths of the app into two categories: compatibilities and reach. Compatibilities means that the application can provide more user functions, and reach, on the other hand, meaning the app or the content can be accessed by more users. Native app has deeper integration with the device hardware, so more CPU power and more native hardware API support for more functionality. This is probably the major reason that why most of the users feel like native app is a fancier version of the experience. But without downloading the app, you are not able to access the content inside the native application. Web app tend to be more static, but unlike native, the content is easily to be discovered, shared, and accessed across different devices. We at Tinder realized that not all of our user has the luxury to have latest mobile device with big storage, strong device power, fast network, or unlimited data plan to run our native clients. This is especially true when we're talking about our international markets. Just in time is really excited that the landing of Progressive Web App or PWA. PWA is a collective of the web technologies that helps to fill the gap in between native and web world. Because of this, we decided in 2017 to start the web project. We want more and more of a user be able to use the app anywhere with a relatively light required resource. So what is PWA? It seems to be a black magic that just mysteriously fixes all the issues from both worlds, or it is some silver bullet that you can use to solve all the problems. Partially it is true, but I hope you will get more clarification about PWA after today's sessions. There are three main pillars when we talk about PWA. It's installable, reliable, and capable. Installable meaning that your app will be able to run in the standalone mode rather than just in the browser tab. The installed app can be launched directly from user home screen, docs, or text bar. The experience of searchable and switchable app will be feel like installed native applications. Technology-wise, we use Service Worker and Web Manifest. Both of the features are supported by all the modern browsers now. You can even publish your web app into Samsung Galaxy Store or Google Play using Trusted Web Activity, or TWA. Tinder actually published a light version of the Android app called Tinder Lite using TWA. And the size of the app is extremely compact and providing almost the same functionalities our native Android client did. Using TWA also has the benefit to release code without publishing a new Android app, and you will be able to easily run different experiments and shipping very small bundles to your users. After your user is able to install your app, the next important part is to make your app reliable. Reliable meaning that the app needs to be running reliable regardless of the network conditions. Native app can use it because there's a lot of cache storage or background fetching strategy and a lot of CPU that is or functionality support the reliability. For web, that's the importance of web performance. At Tinder, we spend majority of our time developing and experimenting different performance strategy, such as code splitting, network priority fetching, tree shaking, pre-caching using Service Worker, performance budget, and more. There are also a lot of good tools for you to benchmarking your performance strategy, such as Lighthouse and Web Page Test. We realized that our users actually have a higher expectation for the web app to be function exactly the same as the native application rather than the downgraded versions. That's why it is so important for us to have a good performance strategy to make our app feels like native. I want to mention here about performance. Performance is unlike like feature development. It's actually continuously improvement or progress. There's no silver bullet that you can reach the performance result just right away. And there's a different angle for you to review and shape a different performance strategy when you are targeting a different issues. Take Tinder, for example. When we start a project, the most important thing for us is to improve the network loading time, which is the browser load time, dump content loaded events, and the browser parsing time. We optimize a lot by smaller bundle size or inline style or reducing network connections. But after that, we shift the focus into user interaction, which is the runtime performance. Imagine you have a button, and then when user click it, it takes a long delay when the button react to the user. That's mostly possible because you have a really busy main thread. This is something that you want to optimize using a totally different performance strategy. Another example is because we are all in the single page applications, when user clicking a next page for navigations, how fast is your web app able to render whole page on the user device without user feeling janky and laggy? The next part will be capable. As I mentioned before, native apps tend to be more powerful and have more features because they have the capability to reach the device API. However, this is drastically changed on the web world. There's a lot of modern browsers now publish new API to fill the gap. And more importantly, a different browser vendors now working together to form a better open web standard. Sometimes you can even use the brand new API across different browsers almost in the same period of time because browser vendors now prioritize the feature in the same page. This will be the main focus of my sharing today to introduce you some fun browser API that we use at Tinder to make our user experience much better. And hopefully you can find some API interested and useful for you to use on your web app. The first API I'm going to share is actually not a new API. In my opinion, it's probably one of the underrated API. It just recently got wider browser support, which is the Media Streams API. It supports streaming video and audio. It is part of the WebRTC group, and the feature group is adding more features recently by different vendors. At Tinder, we have photo upload features. So we use the Media Stream API for a customized in-app camera at Tinder. This API will stream user camera so we can render the more integrated experience in the app. This provides a lot of flexibility for us to have a different layout or different design comparing to using the device default camera interface. This also allows us to enable the photo upload features on the desktop device if they have the webcam. To access the stream object, you can just call navigator, media devices, and get user media. You can then use the stream object to render in the video tag, or like us, using Canvas to render the frame. Not all the browsers support this feature, unfortunately. So for the fallback, we decide to use the native HTML input elements to allow users to upload or capture photos using their own device system. It is strongly recommended here you always seeking for native HTML support first before moving to any JavaScript solutions. The reason is that HTML spec tend to have wider support in terms of browser rendering or accessibility features such as keyboard support, focus style, or voice-over support. In fact, we actually roll out this fallback logic first at Tinder globally. Then we progressively be adding the media string API support to improve our user experience. This is one of the strategy I want to share to you today is we build something on top of a basic features or basic API in order to work for all the users. And then we progressively add more feature or improve your code base later on. At Tinder, we use this approach for our core features. The core feature is the features that all the users are able to use regardless of your devices. The next is not really an API, but it's a concept. We call it adaptive loading. Traditionally, if we want to decide a strategy for delivering your resource, such as JavaScript, CSS, image, or video resource, we probably have one or few predefined strategy or how you load the assets. For example, image prefetching. You probably run a bucket test to find out the optimized value of the concurrent network you can make for image prefetch. But the result and the value will be then predefined, and it's not really reflecting all the user experience in the real world, especially for the people that's considered outlier from a statistical point of view might suffer from this predefined loading strategy. Adaptive loading here is actually an umbrella of the implementation using different browser API to dynamically provide different loading strategy in runtime. There's an API called Network Information API. This API directly provides the system current network conditions. Before this API, we usually just calculate the network condition by ourselves by, for example, fetching a dummy image or dummy resource and to calculate the download time with the bytes. This API is relatively new, but is supported by major Android devices, and which might be the device or user is very sensitive or vulnerable to the network conditions. You can access the user effective network type by accessing navigator connection effective type. The value can range from slow 2G to 4G. And the value is determined by the combination of the recent observed round trip and the download link value. You can also check if the user is in data saving mode by accessing navigator connection save data. When user is in data saving mode, user usually does not want to download a lot of resource. They probably have limited data plan, or simply just want to preserve the battery to not downloading the different resource. So how can we utilize this API to form different strategy in the real world? At Tinder, we actually implement a route-based code splitting, and we preload the next page resource or asset set when people landing on the page. Take our login page for example. When user land on our login page, it's highly possible that the next page they're going to visit will be the main swiping page or the profile page of their own. So we will load these two possible pages right after land, and then when the browser is idle. There are multiple ways you can form the mapping for your navigation. At Tinder, we actually combined static mapping and also dynamic detect for your link level components, which means that when there's a nav link that for client-side navigation get into the user viewport, we will try to fetch and the next page resource when user browser is available. However, this browser actually have a limited amount of the parallel download resource. It's critical to yield the download quota to high priority resource. We noticed that when user is in bad network condition, preloading or prefetching actually harm the core experience due to the reason that the main resource or important resource might got deferred or the device CPU is occupied. We decide to only preload the next route when user is in good network conditions. And for browser not supporting this API, we just simply fall back to our initial logic. We also have several adaptive UI examples to provide different user experience based on the network conditions. For example, we have a video tag to display an animated GIF, and we disable autoplay when user is in bad network conditions. We also pass a poster attribute to the video tag. So the browser will know that they will only need to download the static image as a poster without the real video resource, and they will download the resource after user interact or click the items. By utilizing the network information API, we see an uptick of some of our core user metrics, such as more page view, more UI click, and lower bounce rate in sometimes. You can also have some other API for you to have different strategies, such as the concurrent links value or the browser CPU power or CPU busy status now. Other than those implicit information you can get from the user device, there's some direct user preference you probably want to honor on the system level. As like front-end or UI engineer, we always love the fancy or trendy animations. But this might not be good for all of our users. For example, If user has motion sickness, it will be really not good for them to see parallax scrolling or fast zooming or rapid UI animations. And motion sickness is actually much more common than you're thinking. You'll be able to access user motion preference setting by either JavaScript or CSS. At Tinder, we use a universal CSS selector, which is a media query, to disable the animations. You can notice that we still keep a really short of the animation durations. This is for the JavaScript components, which listening to the animation end still be able to function properly. You can also see if the user device is busy or the CPU is busy and deciding to disable the animation. This will be especially useful if your web app is supporting low-end devices. Animation could increase the difficulty for user to use your app. There's some other preference APIs such as preferred color scheme, which is dark mode or light mode. Or there's some more API that's still in draft, but it could be coming up, such as preferred contrast or preferred transparency. This API direction reminding us that we should always make our app accessible to all of our users. No user should be left behind or feeling uncomfortable when they're accessing your page for accessibility reasons. The next API I'm going to share is the Web Share API. This is part of the web compatibility project that's currently going on by a lot of different browser vendors in order to close the gap in between native and the web app. This Web Share API is particularly useful if you have building a media content focused web page or your web app has a lot of sharing features. This picture probably reminds you some good time when you're trying to build the sharing features. The problem is we have just way too many social medias that you probably want your user to share, but there's only limited space you can have, especially for mobile web. You probably also did some experiment on bucket testing to see what is the most common sharing widget your user is using. The result could be really different from depends on your user demographic. This is probably not the best personalized experience we can have. Some user might not even use any of the app that you provided. And for the implementations, you will probably need to rely on like different websites implementation and then constructing different payloads. This will be really challenging and hard to maintain for your implementations. At Tinder, we have a feature to share your own web profile. We utilize the Web Share API in this case, and it allows us to use the device native sharing mechanism. We don't need to build tons of different sharing buttons anymore, and user will be able to share the content via their favorite app. The Web Share is a promise-based API and can be used to share like URLs, tags, or even files. The implementation is pretty straightforward. It's basically called Navigator Share, and there's a standard payload for you to share, and it will just trigger the device default sharing mechanism. Users are able to choose whatever app they install with the sharing function and sharing to their social networks. You notice that I put a condition check here for Navigator Share. This means that not all browsers support this feature, and this is probably one of the required field you need to have if you want to adopt a new browser API. So what is the coverage of this API? It looks like a lot of red here, but due to the nature of this API, most of the function is used for the mobile devices. You can see actually like iOS Safari or Chrome for Android supported this feature, which means that probably all of your target user will be able to use. This brings up to my next sharing. For when you're adopting a new API, what if you want to support or you need to support more browsers? A question you need to ask yourself is, what is your target device or the browser metrics? Knowing the breakdown of your user device will help you to form the strategies that we can have a different delivering features strategies. Yeah, we need to have fallbacks here. In our case, the sharing features, you can fall back to the original sharing widget. This is particularly useful if you have a different layout for desktop and mobile. The second option is also what we have at Tinder, is to fall back to copy to clipboards. This is a really straightforward pattern, just like you can check if the function is supported by the browser. If not, you fall back to another UI logic that handling most of the same case. This is one of the approach that you can have to have a totally different UI sharing logic, or you can try to mimic the same UI by JavaScript implementations. Sometimes there will be polyfills for you to use, for example, canvas to blob. It's not supported by old Safari, but it will be able to polyfill. Another fun API we are sharing here is the badging API. It's just released recently, and it provides a way for you to set a badge on your app icon just like native. It's really easy to use, just calling set app badge with the count, or clear app badge if there's no count. I use effect here in order to demonstrate you how you can use in the React ecosystem. It's currently supported in Mac OS, Windows, and Chrome OS. It's currently only support in foreground, but it potentially will support in service worker, so you can upgrade your app count at the background. Related to this feature, there's also another upcoming feature called the Shortcut API. The App Shortcut API lets you to create an app shortcut for users for when they are long pressing. They will be easily to see a menu, and they can jump into the specific page after they click it. The last thing I'm going to mention today is Project Fugu. It's a project driven by Google Chrome team and specifically for browser compatibilities. You will be able to see a full list of the new API as well as the spec and the proposal with the roadmap. You can also be an early adapter to opt in original trial for experiment and feedback to the teams to form a better API standard. You can see the spec of different browser vendors' signal of like whether they are going to implement it or they're considering or they already delivered. There are lots like good or fun API coming up. One example is the Contact Picker API. It is going to be delivered soon, and then it will basically let you to access user device contact if you are building a phone app or a messaging app. The Web OTP API is providing you to autofill the OTP code. OTP means one-time password. If your app requiring a SMS text verification, you can access the full list of the API tracker and see the progress and the release date. More importantly is you can able to submit your suggestion or your use case in order to help the web to be forming a new API to support different features. Let's recap. What is PWA? PWA need to be installable, reliable, and capable. You can always start from a really basic implementation using the basic API, and then you progressively add different features on top of your web app. You have to understand your browser and device metrics in order to decide what is your fallback logic or how you're going to adopt different APIs. So what will be the future of the web? It's a really open question now, and it depends on every individual here. Without those experiment feedbacks or tryouts to the vendors, it's hardly possible to make the web compatible. There's a lot of new API coming up, and web app can for sure be more powerful than before. So it's our responsibility to shape the future world. The web should be high performance, discoverable, and accessible to all the people around the world. We know the importance, especially at the time of the pandemic. There's a lot of information that is urgently needed by all the people, and the most shared way is by the web. So we don't want user not able to access the information because your web is slow or not accessible, basically. So thank you for your time today. If you have any questions, feedback, or thought you want to discuss or share with me, feel free to contact me by Twitter, and have a wonderful evening. Thank you.
Okay, Roderick, you're live.
Hi.
There was a question. You mentioned that the PWA is lightweight. Is this compared to a native application or compared to Cordova or PhoneGap?
Yeah, correct. So because we publish the PWA as the Android app, so we are comparing to the Android full application that we wrote in Tinder. So the size of the old bundle for JavaScript bundle and the Android app is probably like one out of 25 of the original size of the native app. So if user is trying to download the Tinder Lite version, it's pretty lightweight. But also because of the code splitting we are implementing in our PWA. So if user, for example, they are not purchasing our premium feature, we won't download the bundle. So it's like code split, which also make that the total bundles or the required resource much smaller. So that I call it lightweight.
There was Klaus Schmidt reacted to your answer. So basically, if a specific feature is not supported by the browser, then you can't really do anything. Just try polyfills, workarounds, other solutions, and if it still isn't possible, you just have to wait.
Yeah, I think so whenever there's like a new features coming up, we all got excited to want to implement it, but unfortunately it's not really supported by all the browser. But good thing is Chrome is doing like pioneer work. So most of the time, Chrome, like for example, for Tinder, probably covers 60 to 70% of our user. So which means that if you implement it, you actually have those many users that already be able to use it. That's a good thing. Then we need to take care of the people that are using the browser that not supported. So we can either add a fallback that's still provides similar functionality, or eventually we will be just like degrading to a different experience. If there's the browser that's really not support and there's no way we can really do it, that feature become optional to the user that able to use it. But that really depends on like if you are able to like prioritize the feature to be used or not. For example, like we have a feature like native can do is to prevent the screenshot for capturing from your phone, but that's nothing a web can do. In this case, we really cannot do anything about it.
Okay, so there is this terminology or a term that I heard Android developers use, which is called hype-driven programming. You know, like test-driven development, hype-driven development, which is the mobile environment progresses really fast, and there are new things coming out rapidly, and you can get caught up in this hype and add new untested or not really final features to your application. Does this exist in progressive applications?
I think it's the same. especially for JavaScript world, there's like so many, for example, ES syntax, like a new syntax coming up. People got really excited, especially for JavaScript developers. But for us, we were trying to still make your code base stable first. In that case, the feature, most likely we would like to behind the feature flag. So we make sure that the new feature rollout, we can measure the results, and then also to make sure it still functions properly for other browser that's not supported. And for new syntax, a lot of time browser claim that they support it, but compared to performance-wise, like the runtime performance, it might not be optimized like for the regular common JS. For example, like the browsers are able to load the ES syntax directly now, ES6. But sometimes, in some cases, the performance is not as good as after you do Babel compile it. So in this case, you will really need to benchmark and to make sure the code is stable and your app is stable before you adopting any new functionality. Because when browser or V8 add it might not be optimized at that moment. So you will be really need to cautious about how to adopt, but you should be really open to all the changes and try out if possible and wait until the time when it is ready.
So it's a balance, right?
Yes, correct. Yeah. But I will feel like it's a learning every day. So you basically learn all the features and then oh, this is coming up. And you wait until, oh, it's moving to stage 1, stage 2, stage 3. Oh, it's stable now and there's more browser coverage, and then you can start to using that. But before it moved to, I would say recommend like before stage 3, probably because the API spec might still changing. So probably don't like really rush to push into production when it's on early stage. But you'll be able to know or be aware or even like participate on the API when it is in early stage.
So you try it out.
Yes, you tried it out and feedback to the like V8 or whatever Chrome or vendors, and then after it's stable, you can really try on production.
There was a question about from Samuel.
Yes.
You mentioned Fugu, which shows you upcoming APIs, and Fugu is for Chromium only, it seems.
So it is driven by Chrome and Chromium, but the API spec is some of the API spec is discussed within the working group for the vendors. So sometimes even Firefox is implemented earlier than Chrome. Most of so it will has like in the spec they will have the signal for each vendor to see if they are public supported or what is their status of this API. Most of the time, I think its age is already WebKit, the Chromium base. So, but for WebKit or like iOS, it's a little bit not in the group. But like for other browser, mostly you will be able to see their signal to see if they are going to support it, they're developing, or like if different status. But yes, the feature and the whole project is driven by Chrome mainly.
And how backward compatible does your application have to be? Like, I would imagine that you don't support Netscape, for example.
Yes. So we initially, when we start the project, we support IE 11 plus, which is already amazing. And then for like Android, we support 4.4 up. So that's like we are calling modern browser. But there is more API or even just CSS is just not supported. So it depends on the industry. I think, for example, like React is supporting for IE 11 up. So you probably just need to support it. Kind of depends on your business. For us, we probably has less user for IE now, and then for Android by the time it goes. So in that case, we can provide different build for the JavaScript bundles. for different, like we call modern browser and the legacy browsers. So then you can ship even like less code to the browser. And if the browser user is really decreasing, you can deprecate that browser. But it really depends on the data that you have for your user metrics.
That's an interesting question, and feel free to not answer it. But data protection regulations, do they affect your work? Because you have to collect metrics from your users, right? So do they impact your work?
You mean the which part?
Like GDPR, like how you can store and process the data.
Yeah, so I think for social network related site, we are pretty like cautious and aware that the data is sensitive. So we will not store people's, for example, credit card informations that will be going through third party, or we have a special like PCI scope thing that will be totally isolated. And as for the data that you can, for example, the beacon we are sending, the username or ID will be anonymized, so we won't be able to track who like really using. And for GDPR, the main part is cookies that is in the scope, and the user should be able to download the data or request to delete the data. And that's, yes, we will need to be especially cautious about, especially cookies for the web applications. But for us, we don't really use that many cookies for users. It's mostly like first-party cookies that, for example, if you change a language, we store it in cookies. So that's why we can get from server side, like which language you are preferring. But other than that, we don't really use a lot of tracking that needs cookies. So in terms of the scope of the GDPR or the CCPA in California, we don't really has a lot of, we already prepare for that. So I would say, so it's not really a surprise for us when it come up.
Okay, thank you. So Klaus Schmidt asks, did I understand it correctly that you only provide the PVA for Android, or do you also provide the PWA for iOS as well?
So, well, PWA is just the website, so any browser can use it. And what we call it to provide PWA for Android is actually the TWA, is the Trusted Web Activity that wrap inside the Android wrapper. That's only supported in Android. But for example, like Samsung Galaxy Store, they already, you can publish directly your PWA. So it can be explored in the Samsung store. That one we also did. So which means like you can just access the Tinder for like tinder.com anywhere, any browser. But if user really want to download as an app, standalone app, they can either go to Google Play Store to download Tinder Lite, or they can add, if the browser, the OS support, add to home screen. They can also just directly add a home screen to any device. iOS and Android, they're both supported.
Johannes Hsiao, I hope I pronounced it right, asks, do you have an attempt for end-to-end testing and progressive enhancement? Just skip tests for certain browsers, or test that a feature in browsers that do not support it, or what?
I think this is a really good question. We don't currently have a lot of coverage for the new feature that we're testing, but as I know, Popular is probably one of the easiest tools that you can use to test like new progressive web app features that the browser features of. Or if you are using the Chromium-based WebDriver, you can also test end-to-end. So for example, a button click, something happens, but it might not be straightforward to test. As for fallback logic, let me see, skip the test. Yeah, so those tests will be, you will be able to test the negative test case for the browser that's not support, to make sure your error handling or your exception or your fallback is working on the browser that's not supported, which can be done on WebDriver based or cross-browser based test tool. For example, I think most of it like Selenium or WebDriver or Source Lab. But for Puppeteer, there's also like Firefox you can try now. There's like integration for Puppeteers. So those are the things that you can test, but your test case will need to be aware that which browser is supported now, because the browser could catch up or release a new version. In that case, your negative test case become positive.
And Lucas Il asks, does your PWA use the same backend as the native app?
Yes, so we call the same API. So it's the same for the native. I think the only thing difference is because the web app is calling the API from cross domain. It's not crossing from the server. So the only thing is the API needs to be coarse, like supported, the coarse header for the cross domain. But other than that, it's pretty much the same. We do have different logic to handle by different platform. For example, web calling an API could be different or than the native based on the feature request, or the API response could be different, but we are using the same backend. So when there's like the scale or new API added, it will be really easy for a web app to develop in the same time of Android or the native app. And then the web benefit is it could be rolled out pretty easily. We can just push a button and just roll out, and we don't need any like from Google or Apple to release the app. And we can whenever the user open the web, it will be able to download the latest version right away. So the outdated code wouldn't stay in production for that long after the cache expire.
In your talk, you said that you start with the fallback and build your application up from there, right?
Yes.
Is there ever a point when your fallback becomes so rare, so redundant that you can delete it and just and basically your next level that you built on top of it becomes the fallback?
Interesting. So you're saying your question is like we have a 2-layer fallbacks kind of?
Like you started with a fallback and you built on top of it and another layer on top of it, and the bottom layer becomes so rare, like your demo, the data comes in that basically no one is using that fallback. So then do you remove it then?
Yes, so that really depends on the browser support. So if API, for example, in our talk, we talk about the WebRTC support for the screen. So if the new browser, like most of your browser already using that, and there's no one using the fallback logic, yes, of course we will remove it, but that will need to be instrumented. So you know how many users is still using that, because if you remove it and there's still people using that, they will just like crash the app. So that would be doing on a really cautious level. But eventually we will be able to, for example, make that fallback logic become like polyfills. So it only loads for a user that's not supported by the code splitting. So the majority of the user that with the browser support for the feature, they will not even need to download the code for that fallback logic, which probably will be optimized. So eventually the code base will be smaller because the browser support more, and the one that we have the custom JavaScript can be removed or optionally load after that.
Here's a weird question. Do you check competitor sites like Occupit, for example?
This is a really interesting question. But first, to clarify, OkCupid is actually under the same umbrella of our parents' company, which is a Match Group. So actually, there's a lot of dating site is actually the same. Well, we are the same company. So yeah, we share information and we also compare strategies, but we are not really. I think that is like a marketing research approach. You will always need to check competitor. For example, like Facebook dating, when they come out, like all the people saying like it might crash us. So of course we will going into there and study like what they really build. There's something that we can try to see if we can build as well, or is something that's meaningful we haven't thought of the new product idea. I think that's really a common practice for all the social network application or software, that you always need to see, because like when user using like for example 2 different app, there's a really powerful function in certain app, and people will expecting you probably will have it. For example, like video chat. If you video chat for the message app is really common, and we don't have it, that's something we need to be aware. You cannot just always like, oh, we're just never going to support it. So yeah, we will always checking different either competitor or some similar like sister company to check if there's some feature that we should build. We don't have it yet.
And really, at the beginning of your talk, you talked about reliability, and you said that the native apps are more reliable, but progressive web applications have more reach. And can the progressive web application reach the same level of performance or reliability as a native app?
Yes, but so what I say about reliability is more like, for example, if the native app is not open, like there's like cold start, or like it's already warmed the cache, or it's safe in the background, or like native app can, like in Android, can even like background fetch the data, which browser for like Chrome could be limited. We can also fetch background now, but it's like not really well support. And the cache size for is based on the browser. So for example, it's only like 5 megabytes for each domain, or it could be less. So in this case, the thing we can cache will be much lesser than the native application. But the good thing other side is within the scope of the cache that you can use, if you utilize well, it can be still pretty well performed. And like 5 megabyte is pretty enough for most of the test your site. And then the other benefit is to download bundle for like JavaScript bundle is actually much less than a native applications. So if a user has an app that, or has a phone that is like really low storage, like using a web app is much more reliable than native, because when native is like reaching a certain of size and you don't have enough space on your phone, it could be really like not performing well. So in this case, is the web app will be much more powerful, but you will, when you develop, you really need to have a good strategy of optimizing your performance in order to reach the same level. But native kind of just have it for free, or has like a better standpoint, I would say. But web app, if you have a good strategy of how you optimize your performance, you could be like as reliable, or probably sometimes even better in some case. For example, if you are in a spotty network, you just traveling in the bus or something, like web application sometimes will be like much more reliable, or if you are doing the performance well, or like the cache mechanisms.
And you talked about accessibility, and I've been wondering how to match that with responsiveness. So your web application is also available on a computer, right?
Yes.
So most modern websites need to be both accessible and responsive. Is that a challenge to make it both responsive to and accessible for like color blindness and things like that?
I don't think it will be, these two are conflicted. So when you build like a form or a button, you will always want to make it like keyboard accessible and has the label in that, like the way the screen reader can read. So that part is universal. Like when you're building either like a mobile responsive site or a desktop, it will be the same. For keyboard, yeah, if you're like using just a native HTML tag, it's also already support like most of it. So if you have a good HTML spec, the browser already support most of the accessibility feature, but you just need to be really aware of like attribute or thing, or cinematic HTML, which a lot of people, I may say, which more people are aware now, which is a good thing. But for color contrast of the stuff, I think it's really needed to be communicated with the designer or the products of your company, because a lot of time the people just want a specific color, but not enough color contracts for more people. And in this case, it's more like the web developer need to educate the people that make the design to have a good system that have the color contrast, or a good UI not using red or green for like yes or no, because that like for colorblind, they just cannot read it. So those thing we are still learning. There's a lot of accessibility feature that I don't really know. I just learned by experience, and I wouldn't know like some people will have difficulty using that. So those are the things that is our responsibility in my talk. I saying like we need to learn and educate the people that can make the change, like designer or products, to have a better products.
Okay, and Lucas had a question. So when publishing the PWA as a TWA on the Play Store, are you required to use the Google API for in-app purchases?
Yes, so that is the biggest part that we haven't rolled out yet. So Google require all the in-app purchase need to be go through the Google Billing API, but it is not supported for web directly. So though there's no JavaScript directly you can call for making a purchase now. We have credit card purchase in our webs, but that Google require you to be using the payment billing API. So there we do have experiment of making a purchase. There is two way probably I would say for now. One is using the web intent to directly talk to your Android wrapper, and the wrapper will have some handling, and then the passing back to the web app will be using query param or whatever like HTTP request to pass the payload back and forth, so you can make a purchase. That's for us. The challenge is we are using single web application. So changing a URL using a post or get will just make the full app just refresh. So probably not really good for the user. But so that's why another approach is using, like, for example, WebSocket, that you can passing a data, a local host WebSocket server on Android. So you can still like calling the Android wrapper using intent and then passing the data back using WebSocket. I know TWA doesn't support post message as the web view, so post message probably will be limited. But that's probably two approach you can try in order to make the in-app purchase for the TWA.
Thank you for your presentation and answering our questions.
Thank you very much.
And see you around.
Yeah, see you.